Hello everyone, we're going to talk about this week's lab where we're going to scrape all the phone numbers off of a web page using Python, requests, beautiful soup, and regular expressions. Now, we're taking a lot of concepts from previous weeks, so we're using a nested for loop, we're using regular expressions, we're using lists, so arrays. So if you need to look back at previous weeks, go ahead. A lot of this code I've written for you. So again, you treat this week as a puzzle where you're taking various pieces and putting it into the code that I've written as part of this in order to scrape the web page. So let's talk about what we're doing. Let me give you some hints on the lab. All right, so what are we doing? So we're trying to scrape phone numbers off of a web page. Let's look at the web page. I put it in here with all the coronavirus stuff going on. Maybe these phone numbers are important right now. I don't know. I don't want to use Edge. Let me close that off. Nope. All right. And we'll get to that in a minute. So let's open up Chrome. Let's go to the web page once this loads. All right, catalog.tric.edu/about/important phone numbers. What does this web page have on it? A bunch of phone numbers. And what we're going to try and do is use Python to scrape everything in this table. I know there's a phone number up here. I will say this. If you in your lab, I usually don't give extra credit opportunities, but if you in your lab are also able to scrape these numbers in an automated fashion using beautiful soup, I'll throw in 2 extra points in your lab if you do it properly. If it's going to break your code and cause it not to compile, don't do it because I'm going to have to take points off because I always put in there. Usually it's 1 or 2 points just your code even compile. But if you're able to do that and you have a bit of extra time during the quarantining, go ahead and try to do that. But the goal for this assignment is to grab all the phone numbers in this table. These 2 tables. Now, how do we do that? Well, a part of this is understanding HTML and CSS. Now, I'm going to be including other links, other videos that other people have made on this for this week's lesson. This class is about Python. This class is about cybersecurity. Not really here to teach HTML. It's not a programming language. It's a markup language. Same thing with CSS. It's a style sheet. It's not a programming language. But you do need to understand it. You need to understand a lot of different things in this space, and sometimes it requires you to learn on your own. So I'll provide some links on how to do this. So let's talk about strategy. You want to grab all the phone numbers out of this table. How would you go about that? Well, the goal for this week, as we've talked about in the videos, is using web page parsing. So a web page is made out of a bunch of elements, so a bunch of markup. And each of those pieces of markup, the elements have a name. So a table, the overall element name for a table is table. The element name for a row is tr for table row. The element name for a column and a cell is td. So you have multiple tds within a tr. That distinguish basically individual table cells. Now, within each of those elements, you can have a couple things. You can have IDs, so that's the identifier of the element, typically a unique name. And when we talk about selectors, those are prefixed when you're searching for selectors, like through Beautiful Soup with a pound sign. We have CSS classes. They apply a specific style sheet, but they can also be used to identify groups of elements. And those are usually prefixed with a period. So when you're looking at data on a web page, and let's say we have a goal. Here our goal is phone numbers within a table. I guess the first step is take a look at the code, and we want to figure out Are there any distinguishing features about these phone numbers in terms of the HTML elements that we could use? We could run a regular expression on the whole web page, right? That is extremely inefficient. And when you're running this on thousands and thousands and thousands of web pages for open source intelligence gathering, you probably don't have the machine power at home to do that in an efficient amount of time. So what we want to do is reduce the potential data set, and we do that by first parsing the HTML and then running regular expressions. And you can then perform this task almost instantaneously. So in Chrome, we can look at developer tools, so hit F12. And what we want to do is we want to inspect these items. So you can do one of two things. And let me make this a little easier to read. You can right click. So let's say we find a phone number here. This is our target. Right click and hit inspect. And it's going to take us to that area. You can also hit in the top left-hand corner of the developer tools here. There's select and inspect element in the page to inspect it. You can click that and then click on the target element like so. There's also the option Control-Shift-C to switch into that mode, and then it'll take us to the element. But ultimately, it takes us to the element here. So I've clicked on this Adjunct Services, Eastern Campus. Well, let's do Western Campus because that's me. That's the number I would call if I have a problem because that's the office they put us all in. So that's 216-987-5227. That would usually take it to the front desk of Adjunct Services. And we see here that it is in a cell, TD class equals column 3. And then in the text of this element is 216-987-5227. So the whole point of web parsing is to look for patterns. So let's expand all of these rows. And we see that every phone number in this whole table, even this last table down here that's a little weird, we'll inspect this. Everything is in rows and individual cells, and the classes are column 0, 1, 2, 3, 4. And up here, we'll inspect this. 0, 1, 2, 3, 4. All right, so all phone numbers are contained within an element, a TD element, with a class of either column 1, column 2, column 3, column 4. And even then, we don't even need to put the TD. We can make the statement that all phone numbers within this table can be identified as the text of any element that has a class selector of dot column 1, dot column 2, dot column 3, or dot column 4. So there we go. So what we can do then is iterate through every set of elements that we get back from Beautiful Soup that come back from searching each of those class selectors, and then run a regular expression to grab the phone number out of it. Without comments, it ends up being 12 lines of code. It's pretty simple. So, but for a first-time person doing this, it can be a bit confusing. So when you're looking at web scraping, you have to take an approach where you're investigating the structural markup of the web pages. You're taking a look at what properties, what selectors you can use to search for data, and then you're breaking up those chunks of data to then further search the text. So let's look at our approach in code. Yes, I have the solution up here. Not going to show it yet. So what are we importing? First, we're importing requests. We're using requests to get the web page. We're using Beautiful Soup, so BS4, and we're using regular expression. So we're importing these modules. I know in previous lessons I've imported without commas. I've done these on individual lines. You can do it. Python has a shortcut. You can Either do them individually or import them all in the same line. So a nice shortcut for you to use. So first step of the lab, we're going to request the page at catalog.tric.edu about important phone numbers. So line 5, what do? Requests.get, and you put a string literal in there. That's the web page. Hint, hint. Maybe it's on line 3. Put that in there. There you go. So what does that do? It goes out, pardon me, and grabs the web page, which is awesome. It does all of that HTTP request response sequence for you. Next, you want to call res.raise for status. Watch the other videos this week. What does that do? It grabs the request response sequence and fills out the request object stored in res. All right, I've done line 10 for you. Parse the text from the request object into a beautiful soup object using the parser html.parser. So what did I do? I grabbed res.text using, I'm going to parse HTML, and I'm putting all of that into what I'm calling catalog page. Why did I call it catalog page? Because it's at catalog.tri-c.edu, and it's a web page, hence catalog page. So you had nothing to do on line 10. Line 14. We just talked about this as we walked through Google Chrome. So there's a bunch of selectors on this web page, if we're talking about finding those phone numbers out of the table, that represent cells of that table where you can grab phone numbers out of it. Not all of those cells contain phone numbers, so we're going to use a regular expression to further check if there's a phone number and find a match. But to reduce our data set and reduce the processing time our machine has to go through, we're just going to grab those selectors. So part of your job on line 14 is there's a number of selectors. Go back to the beginning of this video and watch kind of what we talk about. Do it yourself in Chrome. Get some experience, but put those selectors. There'll be strings. There'll be 4 of them. Put them in there. And then we're going to iterate through each selector. So we're going to do a double loop. I've also done that for you. Don't worry about it. So how does this work? So we're going to iterate through each of the members of the list or array. So for selectors and selector, so you'll put 4 items, 4 items in there. So for selectors and selectors, it'll loop through each of those 4 items, placing each item into the variable selector. All right, line 20, select all elements for the current selector. So Beautiful Soup, as we've talked about this week, has a select method. And what does select do? It selects the element or elements that match the selector that you've placed into there. Fill in the correct argument. Next, remember I said element or element, so it's going to return a list of objects back. So now we have to loop within the loop, so we're going to iterate through each element. So for each element in elements, now we're going to handle a single HTML element. So now this is where I'm going to have you compile a regular expression, compile a regular expression for finding a phone number and put in the variable phone regex. Next, use that phone regex variable to search for the phone number in the elements text. Now, elements text, previous videos I've talked about how to get the text out of an element. Hint, hint. All right, so there's going to be 2 scenarios here. Either we found a phone number or didn't. So if we didn't, match is going to mean none or equal none, the type none of none type. So if that's the case, just go to the next element. So run continue. Finally, I've only put the first part of this print statement. You're going to print the phone number to the screen. So add into this print statement the phone number of that you found in the match. If you don't remember how to grab the first item or the overall group in match, go back to the lesson on regular expressions. Now what's going to happen if we run this, let's run the solution. Hit enter. All right. We're going, oh, there's all the phone numbers. And what have I done? I've taken this whole web page. Let me close this out here. You see all these phone numbers right here? I've gone through each of the cells on this table that match those selectors, run a regular expression, pulled the phone number out, parsed it, and placed it onto the screen. Now think about how valuable this is in terms of open source intelligence gathering. Let's say you're doing research on a company and you want to find every possible phone number that you could use in an attack. And oftentimes, companies don't properly secure every single web page that they have. So they might have items up there on their website that are PDF files or web pages that include phone numbers of individuals that you're targeting. You could run a web crawler on the whole web page, download every single page, and then run this script or a similar script to grab every single phone number, and then you could have a listing of every single phone number that you could try dialing at a company to try and social engineer an individual. So this is where it becomes powerful. Why would you do this manually when you could literally have a Python script? Let's say you get a contract for Microsoft. Microsoft says, try to hack into my systems. Obviously, it's a little bit tougher than a smaller mom and pop shop, but you say, oh, okay, so you say, I'm going to call people. I'm going to use smishing or vishing to try and attack people. Well, what vector do you use? You use phone numbers. And in order to do that, you have to gather the phone numbers. You could run this script on all their web pages to grab all the phone numbers. You can do that to try C too. What did we just do? Let's say you were running a social engineering exercise on Tri-C employees and students and staff. This is where you would start. You could harvest email addresses. You could harvest phone numbers, names, job titles. This is just the tip of the iceberg, but this is the first step in social engineering. The first step in footprinting before we get to network attacks is gathering data. And you gather data in an automated way to save time, save energy. You don't want to manually do this. So for a handful of lines of code, like I said, once you delete all these comments, you're talking like 12 lines of code. You've now harvested all these phone numbers. Then you just pick up the phone, or you create an AI that can have conversations with these employees, try to extract some data from them. It's extremely powerful. So lots of scenarios you could use this in. Again, if you have trouble with this week's lab, tell me. But I encourage you, try and do this on your own. I've given a lot of guidance already in this lab because I want you to really understand the power of parsing content, parsing web pages, parsing files, looking for patterns, and how this applies to open source intelligence gathering, which again, it's footprinting and organization gathering data. Good luck with this week's lab. And again, if you have any questions, please let me know. And with everything going on, again, please stay healthy, stay safe, stay indoors, socially distance yourselves. The great thing about the online class is we're not going to get each other sick. But again, stay as safe as you can, and good luck.